Hi everybody. This is going to be a pretty impromptu stream. I had a machine die the other day, so my Mac that I've been streaming on for the last 18 or 19 sessions or so finally just gave up the ghost, and I had to. Well, I'm going to have to take it to the Apple Store in a couple of days. But given that I've had 5 Macs around here die over the course of the last year, I think it is time for me to move on. So I'm going to try and run some more stuff on Linux, or at least at the moment on Windows through like the Windows subsystem for Linux, and see what happens. And that's kind of all I got so far. So let's see here. I have a shiny new machine. I have spent like the last day or so getting things up and running. I debated about doing the stream of how to get a productive Haskell environment up and running from scratch, but I honestly didn't know how to do that. So, yeah. Let's see here. Pop over there. I should have WSL up and running. I did do a couple of cute things, maybe, just to play with. Let's see here if I do BI or work in progress. Finite domain solver. So I was mucking around with the Guanxi stuff a little bit. So I figure I can kind of go through some of that. Yeah, the thing was I didn't have access to the old one, so I just had to pick something. And so this is me playing around. So this is just, I'm using the Windows subsystem for Linux. I set up Terminator and I set up just an X server on Windows proper, so I can actually run a decent terminal rather than the horrible Windows terminals. And so that lets me, pop up and do that kind of thing. And actually added more than 2 lines to my vimrc so that it can be palatable. Like you have to stay either down at that like horribly minimalist level that I was using when I was using it on the Mac, or you have to go to something more in order to tolerate it, I think. So I wrote this as almost like a pair programming exercise with Will Bird while he was in town earlier this month or last month or I guess it was beginning of the month, wasn't it? He was in town for Splash. Can I give me a quick newbie overview of the Guanxi project? Yes, I totally can. And yes, it is totally, I can't believe it's not Linux, other than the fact that I'm going to have a harder time dealing with Visual Studio Code from Coda and stuff like that. So it'll eventually bite me in the ass, and I'll have to do something about like actually programming on Windows or actually getting WSL to run VS Code or something. As for Guanxi, what is Guanxi? Guanxi is me playing around with what it would take to build a Canron-like system that does not embrace minimality. So mini Canron is sort of this thing that Will Bird and Dan Friedman and a few others, like Kaselyev and other folks have pitched in over time. Have been working on for doing logic programming, or like relational programming, kind of like Prolog, but directly in Scheme. And it's a beautiful little project. They have some wonderful little results where they've been able to do things like build a relational scheme interpreter. So they have a scheme interpreter as a relation. And then given that, they can do things like find me a program such that eval of q is q, and it'll go find a quine. Or given a bunch of examples, go find me the shortest program under like this kind of funny search that Oleg came up with that passes, like that passes all your tests. That's the kind of thing that Canron can do. And I'm rather interested in doing bigger things. Like I would love to be able to do things like, hey, here's a pile of quick check tests. Go find me, like, and here's a program that has some holes in it. Go fill in the holes such that those quick check tests pass. But in order to do that, I'm gonna have to deal with much larger search spaces than Canron can deal with, and so I'm kind of driven to like figure out how to deal with abstract interpretation and things like that in order to try and handle larger domains. So that's sort of the quick newbie overview of what the Guanxi project is. The name comes from, so Canron is the Japanese word for relation. Guanxi is like the Chinese word for relation, but it carries some different connotations. Like it's like the whole network of relations that you have to deal with in order to get anything done in China. Due to like Confucianism and face and all this kind of stuff. But it also carries around like, so that's sort of like the dig at Canron, and then the sort of dig back at myself is, of course, that it's commonly viewed as a source of all this corruption and problems and overcomplication. So I freely admit that I'm going to over-engineer things here. Was that a sufficient crash course contemplation? And sorry, I haven't actually had a chance to get around to reading your thesis. I've been off doing other things. Man, the only problem with this desktop layout is now I have to put my Twitch feed way off to the side on another laptop. So it's a little bit out of my field of view, unlike normal. So, if you feel like I'm not noticing chat, let me know. I'll try and pay more attention to it. Close that other window because that has a bunch of keys on it. All right. All right. So yeah, so at the moment I've got VI set up here, or NeoVim set up. If I do this, I should be able to do something like this, that say :ghcid, get it to actually run ghcid on my code in passing as I save. And so to test that, if I save this, it should start complaining. So I finally have an actual IDE-ish environment to play in. And this should mean that we don't have to keep the well, at least you could tell me, and then I'll eventually notice it later on playback or something. So this means I don't need to keep that ghcid window up off to the up there over my head anymore. Assuming that this I can work out the kinks on this. It does seem to be a bit of a pain point for me that I think ghcid is smart enough to know when you don't give it an option to run cabal new REPL or cabal REPL, but to run ghci otherwise if you do give it an argument. And so I should probably just make a little ghcid like command line tool that does the same thing but does it for new REPL or does it for new exec of ghci, just so that I can tweak the NeoVim ghcid trick that I'm using here that is just straight up in the repo for ghcid, so it's not like I did anything novel. So yeah, so I should be able to actually run this little toy find a domain solver. So what I did here was I just built, let's see here, main, a minimalist kind of like Overton style finite domain solver, like as a programming exercise, just while sitting with Wilbur, just to kind of show him like what is even like programming in Haskell for this kind of stuff. And that was a fun little experiment, mostly because I think it kind of weirded him out how much I aggressively refactor while working on the thing long before I ever get around to it compiling. It did work first time it actually made it through the compiler though. So here I was just going to go through that and use it as a bit of a tour. The syntax highlighting here is basically I just stole this GHCI color thing from RISD. I don't know Riz's last name. I had to kill his char highlighter because it's a little broken and I didn't want to fix it, but it's enough to give me pretty little cool blue highlights and stuff like that while I'm sitting here in GHCI. I thought it was adorable. That's the problem. I don't do tooling because I will get lost in tooling for a month and then come back out the other side. And then when I reboot, when I lose the machine, I'll just have lost it all because I probably won't have bothered to move it to another machine. So this is one of the reasons why I deliberately avoid doing this to myself. So what did I do? I moved to a new machine and then I had to do all this crap. So, all right. So let's see. We had this tiny little finite domain solver. So last time, I think we talked a little bit about this key stuff that I have in there, which is just straight up stolen from ATSI Vanderplug. So you wrote this little paper called the key monad. I'll dump it in the... oh, crap. That is the first problem that I have with this new workflow. I can't dump things directly into chat anymore because I don't have Twitch chat running on this machine. So that's the problem with having it on the other machine. All right. I have to kill my audio on this machine now. Oh, bugger all. Wants me to log in on my phone, punch in security codes. Live on stream. Hey. There's a bit of a race condition there. Yeah, I could maybe slide it up a little bit. Let me kill the echo that I'm getting from myself. Why am I not able to kill? There we go. I managed to finally kill the echo. And the whole reason I pulled up... So the problem is I'm going to have to slide it over in order to get into Twitch chat, in order to paste links and stuff. There we go. There. There's no good way to just get the chat. I guess I can just start IRC and IRC Cloud and point it at the Twitch server or something like that. I think I've done that before. At least that's where I pointed the bot. Maybe that would be a way to do it. I'll do that for a future stream. This is the kind of thing that I'm trying to get the kinks shaken out like today. So I expect this to not be the most informative stream I've ever done. I will minimize this. So the key monad thing is just that you have some monad that can generate keys, and you can test keys for quality. And it's like working with, click the gears. Hold on. I will take that if it works. Where is this? Click on the gears and click pop out. Hallelujah. Sweet. Can I close this window? All right. Well, that's a lot more convenient. Now I can keep chat above my head, and I can shut this whole other laptop down. I am sold. There. That's so much more room. Wow. All right. Hey, Puffin Fresh. Thank you for, I think, your 7th consecutive subscription. Indeed it was. All right. So let's see. So what do I want to play with today? Oh, I can't do that with that mouse. That is for the controlling the other stuff. So I'll drag this down here. By me, can I make this really short? Can we get my face? You can probably get whatever emote you want at this point. I think you have won the emote selection criteria. So if you have the machinery for making the icons or whatever, I'll happily try and figure out how to instantiate it. I think you already did the Haskell logo, so I don't really feel the need. All right, I'm going to use this to test the thing. No, go away. Pop this up here. Hello, Chrome window. Can I not just grab the corner of that thing? Why can't I? I'm just super finicky about how narrow it is. Come on. There we go. Now I just want to test a thing. Screen sketch. Woohoo! Yeah, it worked. All right. Got this stupid stylus thing with the laptop, so I figured I would try and see if I could use it. It's a HP Spectre or something. It was what I could get that wasn't an Apple when I went into the Best Buy. It wasn't a terribly exciting purchase. It was smallest thing I could get with a 4K display. But it does the 2-in-1 silliness and all that kind of stuff. Not that I think that what I wanted was a Linux box. What I got was all this other stuff that said, okay, well, I guess I'll keep Windows on it and just use WSL rather than lose all that functionality. Which I'm pretty sure is the goal of Microsoft in selling it that way. Why am I using this? So my most recent Mac died, which means that now I've had like 5 Macs die this year, and I'm just done for right now. So I figured I would see if the grass is greener on the other side. So now I've got a Windows machine that's doing the OBS, talking to a Windows machine that is my development laptop. And I figured I would at least try like just doing the development on WSL for a little while. I was going to do this with a VM, but then I remembered how much hell it is trying to do Haskell development on a VM because you don't get to have all of your cores and all of that kind of stuff. So at least with WSL, I can just say jobs is number of CPUs and stuff like that, and I can use all my cores rather than have like half the resources just arbitrarily taken up by other stuff. So right now I'm using WSL and running VCX or whatever it's called, on the desktop, so I can run Terminator to actually have a decent terminal window. And that's about all I've got set up so far. I went through that and then like set up color settings for Vim and set up GHCID, and that was my day. And that's not exactly how I wanted to spend my day, but I got it out of the way. Maybe what I should have done is spent that time learning Nix. Would have made you happier, but you weren't around. Or at least I didn't reach out to you, and so I didn't have that resources on hand. So anyways, finite domain solving stuff. So, like I was saying, the thing I did do was sit down with Will Bird and try and mock up a tiny little finite domain solver as a... how did I get the dark colors for Chrome? I just downloaded, I said dark theme for Chrome, because once I had my window for whatchamacallit, once I had my terminal window like as dark as it was blinding. Yeah, talk to him about Nix too. Oh dear, I don't want to run Nixos. I do want to run Nixos, but then I don't. I will be converted. I accept this. Maybe just not right now. So the thing I've got here right now is a tiny little finite domain solver, except the only thing that it does, like other than like what David Overton's finite domain solver from like 2008, like I think David Overton. Wrote a little blog post back in 2008 on constraint programming in Haskell. And in it, he describes this kind of scheme of like, you set up a bunch of, like, I have variables. They like, let me blow this thing up, I guess, because it's probably going to be a little too hard to read. I have x and y lies between 0 and 3, and either x is less than y, or x is the same as y. X has value 2. Give me labelings of x and y. This is the way he solved it. I didn't actually have access to the source code for this when I was writing mine, so I just vaguely remembered the style of it. And so he builds things, the thing up as like a state monad, like state transforming lists, and he's got a like state for what applies to his variables. We might well do that. I would be interested in doing a maybe a Twitch / pair programming / how the hell do I get this Nix thing to work session at some point. Finite domain solver. Yes, I can define that. The idea is, let's say you just have like values that range over some finite set of value. You have variables that range over some finite set of values. You have a bunch of constraints between those values, and you would like to like find, does there exist a solution? Like the kind of common example would be like those little puzzles you have, like, where Einstein lives next to Niels Bohr, but like is 3 doors down from somebody else, and so smokes this kind of brand of cigarette, and you know, these people, like they all have different dogs or something like that. And you get those kind of logic puzzles. Those would be a classic example of a finite domain solving puzzle. So what he's got is that his variables have a set of values they can take on, and then some action that it's going to run in the FD monad whenever you update this set of values. And this thing is responsible for filtering other people's values. How does it relate to logic programming? I think they're kind of... Yeah, send plus more equals money is the classic example. That's a good example of arithmetic constraints. Lots of knapsacky things like stable marriages. What other examples are there of like classic finite domain solving? There's like 300 or 400 like standard finite domain solving constraints that people use. They get used all over operations research and all sorts of other areas. Logic programming is kind of a large space, so I would say what Canron would kind of use as logic programming, this is a subset of. This is like something that kind of falls into that bin. So this is an example where I had more code, and unfortunately the rest of what I have was on the other laptop, which I am anticipating I will not get back with a logic board intact, given what's happened the last couple times. So I'm probably just out some code. So one of the things I did to this was make it a little more propagator-ish. So we're stuck with just my fairly naive encoding. Contemplation, no worries at all. So a key here was from that Etsy article, and I put it in the Guanxi repo. What the hell happened there? Something I did went very, very weird. A source, what is it? It was key. What did I type? Oh, colon, bang. Oh well. So again, here all I have is like right now I've just got like key is like a mute var holding a proxy A. So this is like you can construct one. You can't change its type, so it's like it's going to be locked in at its type. And then I'll just unsafe course to do the checking of two keys for quality. And then right now I've got this monad key thing, which is currently just using prim state, which I need to give up on, which means all my examples are going to get more verbose, but whatever. Because I don't want to have to lock... I don't want the user to have to be an instance of prim monad in order to be an instance of this. Because there are places where this is like sound to use and prim monad is not. Like for instance, if I have like a state-teed, I don't know, some list computation or something like that. Working with prim monad under that is really dangerously unsound because I can like freeze a value and then like in another continuation like go back and work with the same mutable thing and then freeze it again. So I would prefer to have this monad key constraint be its own monad. Maybe what I should do is just pull the trigger and make that happen now, because I have a whole audience worth of people. Type key state M. default for this is going to still be prim state m is prim state n. The default for key state key state m is key state n by default. So by default, try to lift new key. So I'll have to help it by telling it what this thing is, or telling it what that new key is prim key or something like that. And then we'll be good to go. Run key is take a monad key and run the computation. ST and IO, you can use the ability to build mute vars in them. I'm going to have to put type key state. No, key state is prim state for these things because they did lift. So these will just remain cheap. Well, that was easier than I thought. Is that everything I need? What's my GHCID file say? This is the thing I need to work on my reflex for. It's :bang vi, which is a thing that I used to do. But now using NeoVim, I have to make sure to use :vi. It's just a muscle memory thing I have to unlearn on a new machine. So we have boxes, we have locks, that's all good. Is that everything I needed here? Oh, I can use lots of things. It's my muscle memory is to do the other thing. From long ago. It's not a particularly rational set of muscular responses to all new build. Let's see what happens here. All new REPL Guanxi. Does that? Do I even need that? So I hit Control M, but then I do this little thing that runs GHCID in my little setup. 63. Prim state M is key state M. Oh, I didn't tell it. But wait, why aren't you? Corbob, no, I'm not. This is not my usual hunting run. I have the machine that's running OBS over there is a Windows 10 device. Other than that, I haven't and doing VR stuff for the last couple of years. I generally haven't touched Windows in years. Kramer, dude, the thing we're doing right now is I'm writing a little program for quote unquote logic programming in Haskell. So it's a one of those things that can solve those little back of the the 5 people who live next door to each other, who all have different pets and smoke different cigarette brands or whatever. Trying to figure out who lives in what house and has what properties or something like that. Those are the kinds of things that I can solve with this particularly small engine that I'm working on right now. I'm using this mostly to hammer out like my environment because my machine just died, and so this is a brand new machine. New key. Why are you not a strict state? Should have a prim state. So prim state for, so my key state for state TSM should be the same as prim state for state TSM, which should be the same as prim state for M, which should be the same as key state for, oh, it doesn't know that's the same as key state, damn it. I'm going to have to actually do that proof. Key state, fine. Strict state TSM is key state M. All right. I'll let other people speak to why Haskell, I think. '69 strict writer T WM. Oh, WEM. Where I got the same mistake down here. Well, actually, having this directly integrated in the editor is rather convenient, I have to admit. Type key state reader TEM. This is going to be a little tedious, but it'll be the right solution, so I'll do it. And Corba, if your question was, I'm not normally on Windows, not just because I'm feeling I seem to be weird in the way I'm programming on Windows. Yes, I'm not normally on Windows. I'm normally running this on a Mac. Although my Mac died just recently, so I said, screw it, I'll go buy a new laptop and won't buy a Mac for once. Square, I think the main difference between Python and Haskell is that, like, here you can see that I'm getting type errors at compile time. rather than at runtime when I do things wrong. So I don't have to. So I can have a lot more confidence when it comes to refactoring my code. So it's similar to C++ in that regard, in that I get more errors. I get errors earlier on in the process. Key state box S. Why are you? Oh, test. Doesn't need prim state M. Prim key. Where's my test for keys? Oh, this is the. So this is the thing I did. One of the things I did on the other machine. Test equality is in data.type equality. So I can just use that directly. I don't have to have test. I don't have to make my own combinator name. It already exists. That's a fun one, Lollicap. I'll give it a try later. Maybe I'll use Ermine or something. It's a real quick thing to do. Online test equality. We've got that. We've got prim state by default. Not in scope. Test on line 92. You're a test equality. Key new key on 104. Why do you need a test prim state? In the expression new key is, oh, this is at end of file. It found this problem in key new key for logic T. Do I not have logic T instances in this? Oh, and logic reflection. Monad logic, monad key. Key state. Is it like, hold on, :CR, is that the? Yeah, that's going to be fast. Type key state logic TM is key state M. Save that. CR. Okay, I can get used to this. Every once in a while I try and change out everything that I'm doing. Right now I'm changing out all of my tooling around my development workflow. Show me the thing, all good. I can live with that. So we've updated, that's in source key. I just need to actually get better at just using the full command. What's the other one? Maybe that'll work. I'm still figuring out a workflow here. What the hell? This thing completely. Work in progress, FD. Not load module key. Oh, because I didn't. Well, new build. That gets me all the things. Build it. Find me the problems. Test equality on that. All right. We're happy. GIC, work in progress. Main. All right, finding domain solver still works. All right. I don't know why, like PWID and LS are just like also muscle memory. So the little find a domain solver that I have here, all it has is when I give you a variable, that variable has some ID and some key, which tells me that I knew a type for it at the, like A, I knew what the type of A was at the time. So like the key here is just that little stref that only exists so that I have a way to get the type information for A. And test var, oh hey, look, I can fix this IAP too. Yep, there we go. I never used it. I should actually also do test coercion. Oh, that's interesting. That's a consequence of moving to NeoVim, I guess, is I can't just drop into command line tools that expect standard input. I'm used to just being able to run commands here that take standard input and do things. That I think is the I guess I'll just have to start doing it in another window. What was I doing here? I was loading GHCI. Not GHCID, I was just GHCI. GHCI. Oh, man, that's messing with my muscle. Data that type coercion. You are test coercion. Oh, stuff. All right, and I should probably do the same thing to the key. I could probably do this by only having this thing do unsafe coerce and have this thing use test equality, but meh. All right, so that got us key cleaned up a little bit. Throw that off to the side. I'm going to steal a little more of the screen back from you. Sorry, contemplation. Just so I have more wiggle room.
Last of the lemonade, so.
All right, I'll take the last of the lemonade then. Thank you. What do we have? Test coercion's done. Work in progress. Find a domain. Start this thing up. Test equality with test coercions. All right. So variables. Given two variables, I can check them for equality, even if they're var SA and var SB, and if so, I will then learn that A equals B, or I'll learn that they're different variables. A var set is used internally when I'm evaluating constraints. In particular, it just sort of borrows the semigroup and monoid structure from int set and can be kind of, it's the underlying set of the integers for a bunch of variables without the key information. And so I can construct a singleton one from any var. Constraints are going to be the things that I cause to fire whenever I update. And so here what we have is a constraint SA. S is going to be the region parameter like we had for key earlier. We'll take a set of A's, which is the updated set of values that A can take on, and we'll give you back, with side effects, a set of variables that need to be updated. That's what a constraint is. And then I can smash constraints together. So for a value, in the environment here, what I'll need is, what is the key for that value? What are the set of values it can take on? What are the constraints that need to be, what needs to happen when I change it? And this is the value. And so my environment is now just a supply of fresh IDs and a map from ID to value. And then my little finite domain monad is just state T, plumbing around this environment through logic T. And I'm doing that on top of ST so that I have, this gives me my key supply. That's all I'm using it for. This gives me my non-determinism. This gives me the plumbing of my environments. So the end result is that I want to be able to run little programs that look like this. Give me a bunch of variables, in this case using a bunch of integers, and in this case a finite domain constraint on booleans. Where x is less than y, and y is not equal to z, and x is equal to z, and w is false. Go force all of these down to ground terms and tell me all the answers. That's the kind of program I'm trying to run. So if we want to skip ahead to the kind of the punchline, this is where I'm going. But I want this to be strongly typed. I want to be able to have new var work for ints as well as bools, unlike the little Overton solver. So for that, I need this key system or something unsafe generally in order to produce it. So the only real interesting piece of machinery that I have here is creating constraints, and then the little lens that lets me poke at a val with a key. So again, remember I have these vals because I really want to have a hash map from key to sets of values and constraints. But I can't actually encode that without, I think I have stable maps, which tried to provide this functionality, and we've tried this with a few other things. In the end, I think the typable version is the only one that's really left sound. David Foyer has been playing with it, and I owe him some of my attention and time on this issue. And so using key here lets me not have to incur typable constraints on the things that I do new var on. And that would matter to me if I wanted to allow region parameters to pop up inside of there and stuff like that, which could matter later. So that's sort of the motivation behind caring about the key. So to create a new variable, go allocate a fresh key, go allocate a fresh ID, set, given a set of values that variable can take on, go insert into the content map. For this ID, here's the value. It has this key. This is the set of values, and it has no constraints. Nobody needs to be told when this thing updates. And then the rest of this is just sort of, given a variable set, how do I fire the set of outbound propagators? And all I'm doing is pick something out of the set. If there's nothing there, great, you're done. If there is something to pick out, go look at the value, the set of values it currently has, and the constraint that needs to be run when that thing changes, because this has changed since the last time we've called these things to fire. Go tell them that this has been updated, and it gives me a set of other things that need to fire because they've climbed in value, and we're going to fire that. So this is kind of in the propagator scheme. What I think we'll maybe do, maybe tonight, maybe not tonight, is do a version of this that's more explicitly propagator-like, where instead of having a var s a, I'd have it like a var s set of a or something like that. And then we could have different things other than set constraints to play with later. All right, new var fire. So fire is kind of the workhorse of all of this thing. All of this, it's basically just running through the var set, growing it as we get knock-on consequences, and shrinking it as we discharge individual constraints through min view. So min view is shrinking it, and then run constraint is giving me a thing that we're then appending in, which is growing it. And the main workhorse that I use here is this like notion of a mutual constraint, which is like if you were to give me the two sets, like say x and y, and I say that x is strictly less than y, tell me how to update y and tell me how to update x as separate constraints on each one of the things. So if you told me something about y, I'll tell you something about x. If you told me something about x, I'll tell you something about y. And then this is just append this into the constraint for this variable. And then, like, judging that something is strictly less than something else is, well, if they're the same variable, x can never be less than itself. Otherwise, go in here and then carefully split out like the largest thing in one of them, like, is smaller than the, yeah. It's really tedious. But that gives me the ability to check to see if two sets, if one of them is known to be less than the other, I can take the largest element of one of them and use it as a cutoff for the other. And vice versa. Inequality constraints are only useful when we're down to one thing. Equality constraints, forcing things to be exactly equal to a value. And then I have some code here for like running through the environment and then grounding out all the terms. This was probably the most tedious code to write here. This probably would have been very useful to write on stream. I was just at a coffee shop at the time and was working through it with one person rather than 20 or 30. Here what I do is I loop through the keys of my map. Again, my map tells me from each variable, this is the set of possible values. For each one of those values, construct the variable, right? Because we know the ID that got us to the val, and we know the key that's associated with this ID from inside the val, so I can construct the var and then force this one term to run to ground. And this thing here is kind of a pain in the neck in the sense what it has to do is it has to go look at the set of values that this thing can take on, and then for each one of them, it tries to do the fair-ish interleaving that Logic T offers us. And it fairly interleaves trying out each one of those alternatives. So that's what val does. It's kind of like forces one variable to ground. And then ground tries to ground out all the other variables. So beyond that, it's really just a matter of given something that's in my finite domain engine, run it as at least reduce it to a logic T program, and then given logic T, I can observe it either trying to run it for one target and then failing with an error if it's not there, running it to n targets, or getting the first n results out, or getting all of the results out. That's all I've got here. So that thing runs now. I look at the output, yep. right, so Joey, no problem. I think we're not really well equipped to be a Q&A forum for that. So what I'll do is I'll copy this, find a domain solver version, and we'll do a cheesy little propagator version. Yeah. So now, what do I want to do here? I want variables will be described by like the lattice of constraints on them or something like that. Yeah. So we're not going to have a set anymore inside of here. We'll have whatever lattice you want to have. We'll update them by some internal magic. What do we want? Var set A, that's fine. Set singleton, this is all good. Constraint S A, lost the set. Constraint S A, this is all good. Val S A. So we're losing the ability to do set operations directly. What else do we need to do here? F of x's and y's. So simple constraints will be what are we doing to this thing? We're leaving this alone or we're changing it? So I have to decide on this second one. Can we do a simple constraint that updates a second variable? Or do I need to keep simple as a var s on set B? So we were able to get one of the generalizations. Let's try this. Maybe B. We'll go to the simpler constraints. Constraint, x's, look at the guts. This is the value. If f of x, y's, it's nothing, that means that we failed to update, then we're going to give back if we failed to update, then nobody has to fire. Okay, otherwise we do. Okay, good. We're all good here. Simple didn't actually have to do anything hard involving sets. Unlock val. We just get back an A. That was easy. The guts of this thing just give me an A. That was tough. So new var is just going to hold on to that thing. Fire works just fine with a var set. Okay. So now we finally got to something that needs a set constraint. So I need a set of A's and a set of A's. And then I can establish an LT constraint. Right. Set, min, view, do all the things. So all we've done is shove this around a little bit and get rid of the set specifics of everything. Oh, we're going to have to do something for grounding as well. We're going to have to add a grounding mechanism to every cell or every variable. Because we don't necessarily, like, for sets, we knew how to enumerate them. Here we don't. Any var ord. This fire singleton val domain solving vol void var finite domainus logic. All this stuff should remain largely unchanged. So these new vars are no longer going to be we'll use overloaded list syntax, which is what we were doing before. Pick up a bunch of constraints, run them to ground. When did I start coding? I started coding 35 years ago. I was 8. I had a very different mindset back then than I do now. All right. So instead of a var or a val being a key, a value, and a constraint, it's going to have some finalizer or something like that that runs this thing to ground. And then to put those together, I guess I don't need it. I just need to tell you how to clean up after yourself with that thing. FDS unit. Different mindset. So I used to be very systems oriented. Like I had when I first started programming, I was like in assembly on the Commodore 64 and really kind of quickly lost the concept of a variable and just remembered that there were like addresses on the 0 page that were faster than other addresses. And so I used those for everything that I could. And because my indexing modes ran through them whenever I needed to deal with a 16-bit value in main memory, I would use them. Not basic programming. I was getting out of basic programming and directly into 6502 assembly. Was one of the first things I did. type finalizer or something. I guess or something like that. Yeah, so we propagate and we guess. Somebody have a good name for a guesser? Or approach for guessing. It's like a strategy or something like that. Strategy picker. I'll go with strategy for now. So now, with strategies in place in my values, that means that we have fresh content val. That's fine. Simple constraints are simple still. Unlock vals will no longer do that. We'll also get a strategy. That's a mess, but whatever. Got to give me a and a constraint and a strategy. I'll just this is no longer an uncurry. Yeah, that works. So when I go to construct one of these things, I'm going to have to give you both an A and a function from A to FDS unit, which is the finalizer and the strategy. We'll load them both in. We go to fire a var. This doesn't care about the strat. Mutual doesn't care about the strat. LT doesn't care about the strat. Val. Val is going to rely on my strategy, running it down to a unit. Jim Butterfield, Commodore. It's not a name I've heard in a long time. Jim. Do I know this guy from anything? Moss Kim 1 pet. He's my uncle's era more than mine. T-Bug software library that I'm familiar with. only commercial market program with Spell Pro. Yeah, definitely. A little before my time. So I didn't really get involved on the pet. Had an uncle who had one, but I didn't. What is my opinion on Linus? Oh, wow, that is an incredibly polarizing question. I'm almost going to plead the fifth. I think he's an incredibly smart dude who can be incredibly abrasive. And that has been a survival strategy for him that has been quite useful. That's about it. I mean, I'm working on Linux using Git right now. He's been reasonably influential in my life. Folder leave. How do I do this val thing? So, I was going to run a var s set a. So we're going to run the set all the way down to values because we know what it is. So this is actually something we can do. We don't need to let you run me to ground. We can just run ourselves to ground. Oh, man. The problem with this font size is I definitely can't read that. Which is a shame. Control Shift plus, can I get... Do I have my... I don't have my Chrome plugins for something. Sorry, Super, I can't make that out right now. Catch just... Yeah, I'm going to have to give up. Just because I'll derail too much. Calling the relationship. So when do I test it? Oh, the only the goal for that grounding or the strategy thing that I mentioned was to use it when I get to ground here. Because here what I used to be able to do was use val over and over again. But I can't because now I don't know what that would do. But I can go in there and go grab its strat for evaluating to done, basically. And then just feed it the current value for that strat. So we can just run strat of A. And I don't even need to care about what the type is anymore. Or what my variable ID is, I think. College did I go to? I went to a little teaching college called Eastern Michigan University. Much later in my career than most. So ground's going to run through everybody using their grounding strategies. And take whatever anybody says is grounded. Environment 0 empty, that's all good. We run everything determination. All of these things are set constraints, which is still okay. Is that everything I needed to do to make this go? That would be really pleasant. Val should have 4 arguments, we've been given 3. I expected some of that stuff. You don't care about the finalizer. To do new var, I need to give it a thing that runs it to completion. What do you do? New set var, or new set var is a var. This is an we're going to take a set of A's and give me an FDS of a set of A, or var S set A. So a new set var should do these things. Do I support medical marijuana? I support general marijuana. I don't happen to partake really at all myself, but people are welcome to do so. New set var. I might have to be very careful about when I pick up OR constraints. I'm going to use the set. Set var. Where my strat does something obvious, kind of like this isv thing. I support medical LSD. I don't know that there are any known medical use cases for LSD. LX says use guts of that, get the value out. Strat does that. Is does that. So I can fold our strat directly into there. I'm going to give you the TLDR on what I'm working on. Right now what I'm doing is building a little library for doing kind of those back of the book logic program or problems where you've got like people living next door to each other, and so and they all have different animals, and so and so is 3 doors down from the other person. That's what finite domain solving is. This is a toy to exercise some of the components of a larger framework for doing much more industrial strength versions of these things. And so I've been slowly morphing from a direct finite domain solver into one that's built on top of propagators. And there was a stream fairly early on in this on propagators that goes on for about 3 or 4 hours on them. So if you really want to know what a propagator is, I would recommend going back to that stream. Join, go through the guts of this thing, replacing them using set singletons. All right, that I think new set var is. I think that's a valid finalizer. This is X. Where's X coming from? I need to know my var. I need to not just know this, but I need a whole var S. Where's my finalizer strategy? Gets to know who it is. Which is annoying. Yeah. So now, where did we use strat, or where did we pass strat through? We passed it along here, but now this thing takes a var SA to A. And we juggle knock-on consequences of this thing. Ooh, dead pixels on my... over there. Well, I haven't had dead pixel in a decade. Min view. Get var set. Alright, so the new var thing, this strat just gets passed along completely unmolested until we finally get to new set var, which actually has to pass one in. So we're going to pass this thing E. And we'll call this thing X. Strat where strat X. And then I can drop the E. And then strat X has V associated with it, but X is known, so we know we can get the guts of that variable, look at its values, set them to be whatever we want, as long as they're not. That forces it down to a singleton value. I think that's sound. So new set bar, new set bar, new set bar. Yeah, we'll just let this thing magic. Let's wait through the rest of that. And then we're asking vals of things that are known to be set bars, so that's okay. .168. Strat takes a var. I need the var, so I need enough information to construct the var. So I have an ID here and a key here. And we're going to use IK to construct the var. New set var. Folder join guts. This is new set var is applied to two arguments where this is just new var. .183, and then is has to I think we just do this join. Nuances of ord A from new var. Yep, we need that. That was tough. All right. So this has been switched to a more propagator-ish style. Now we only just happen to have things that are sets, and we only happen to have updates that we ever do that are well behaved. And I think the next step is to start making this thing fit into the rest of the propagator framework. Although I want to switch all that over to keys, and I think I might do that next time. I mentioned wanting this use this stuff way down the line to do program synthesis. How long until it's partially complete enough to write the rest of itself? I think that's the dilemma. I think you got to finish it and then you can use it to write itself. But by then it's already too late because you've already done all the work of writing it. I know, like, Will likes to use his interpreter, his relational interpreter, to run his relational interpreter, because when you start with a relational interpreter, you can put logic programs at certain places in the program. But then when you go one level up, you get more and more places. All right, I think what I'm going to do is I'm going to save this prop thing. Alright, so I think this at least worked out some of the kinks on this machine. Got me back up and running and with some sense of what doing this development on Windows is going to feel like, or at least on Windows. On Linux in Windows, you know, the Windows part is that there's a little bar down here and then I can dig out a pen. I am curious to see, like, what it would actually be, when it would actually be useful to pop out the ability to sketch on the screen. Can't use screen sketch right now. Oh, that was useless. Does not bode well for it being useful in the future. Or these silly little sticky notes or something like that. And, you know, being able to do the little category theory diagrams of you know, fiat X and fiat Y and stuff like that. Whether this would be useful or not as a component to the stream. This is actually one of the reasons why I was willing to even contemplate this, because before I had the sketchbook off to the side, but it was kind of a mess to use because I'd have my hand directly between the camera and the thing it was doing. And so right now that space is space for me to put cans. And not so much useful for the stream. So I'm curious to see how much the pen stuff will actually help, or like if being able to like point at like a piece of code or something like that on the screen will be useful. I think I might need to figure out how to structure this a little bit better in order to make that actually pay out, though. All right, I think we've hit a pretty good breakpoint, though. We've built a little toy propagator engine. What I'll probably do next time is like dust off some more of the nominal set stuff, catch up with where we're at, go through like a little toy on nominal renaming sets that I had started writing at the other machine. As a matter of fact, I got some of that code off of the machine at the last minute, like when it was at 2% battery life and it was clear that it wasn't going to keep charging. So that was like the last thing on the life raft off of the older machine. And we'll see if I can actually get any data back out of Apple this time. If so, then I have a few more of those kind of baby steps towards each one of these projects. All right, well, I think I'm going to call it there. Thank you folks very much. Have a great night.